Today on the bench, a switching mode power supply which only works temporarily. Welcome to TRX Bench. Yeah, as I already said, this is a switching mode power supply with 22 amps output and 13.5 fix voltage. And the beauty here of this power supply, also it is a switching mode power supply, it does not have a fan, which makes it really silent. Therefore, of course, we need a huge heat sink to get the heat away, and that is compared to the known, or the switching mode power supply which you can buy today. They all have a fan normally, and therefore they are a bit lighter than this power supply, but you always have this annoying fan, and that is really the beauty here, that it is completely silent. Okay, so let's see what happens when we switch it on. So nothing so far. So we only see that we have obviously mains, but as we have only an amp meter here, we do not know if there is output voltage and output current, as long we have not connected a test device to it, and therefore our electronic DC load is here first choice. So let's connect here our electronic load to the power supply, and let's see what's really going on. Yeah, and as you can see, output terminals here for this model is here at the back. Which makes sense, because if you use it in your station setup, then it is nice to have it here back on the back side to supply all your equipments. And yeah, so that is quite nice design, like it. Okay, so let's see what we have. Let me switch the power supply on. And yeah, as I can use here my power supply as a voltmeter, you see that the power supply puts out 13.8 volt, which is fine. But for the moment in time, we have no load connected to it. And yeah, I have dialed in a constant current of 100 milliamps. So let's start with 100 milli. And you see, okay, so now our output voltage completely is collapsing, so we do not have nothing any longer. So let me switch it off, but it stays off, or no voltage whatsoever. And yeah, let me, okay, so you may have heard that I have hit here our power supply, and voltage comes back. So let me switch on here my load once again, and you see, yeah, for the moment in time it looks like that it is holding here our output power, and thus as well here our output amps, which is resulting in 1.4 watt. So let me increase here a little bit my output power, and you see it is holding it, but we have seen that it was collapsing when we did it first time. So for sure something is wrong. And yeah, you see I'm easily able to increase here my output. So let me hit here my power supply. No, normally we have seen that it was collapsing, but for the moment in time it is working just fine. So, okay, so we have seen that there must be a problem. For the moment it is working fine, and let me see. So this is, as we know, really a power supply which is able to deliver 25 amps, and you see I'm already at 13.3 amp, and it is working. Now you see it is collapsing, so it is gone for any reason, I don't know. And now I've hit it again, and you see something happens. So it came back, and now it is dropping again. So I hit it again, and you see, so okay, that is telling a bit. Yeah, let me crack it open. Let's see what we have inside, and well, then let's have a look what is here going on. All right, and here it is. So you see, this is really a nice build quality. So we have here our big heatsink, and we have here of course our power transistors for our output power, and we have here our live circuit, so input, and you see for instance here the filtering. So even here on the protective wire, so there's a little core here onto it, and you see here the epsilon capacitors, and the input filtering here, common mode choke, and what have we. So that is really a very, very nicely built power supply, and you see that this is really high quality. And yeah, what have we for, what are the brand of our capacitors? I can't read it. That is Nippon Chemicon. Okay, so it is not one of I would say the top brands, but not too bad. And here on this side I can't see a brand name, and I cannot see, I mean, this here are 105 degree C capacitors, which is definitely fine. I can't see it here for this capacitors. So they all look good, so we have no indications that there might be a problem with the caps. So as we have seen that when we just hit it, that the problem goes away, so it might be that we have here a problem with a loose connection. So that is possible, or well, on the other hand, maybe that there is really a problem here in our circuit. So that is what we need to find out, and therefore the best first step is to take the board off here, and let us have a look underneath. Okay, and at least I have here our PCB out of the chassis, and that for itself is already a nice task. But anyways, it is out, and yeah, if we have a look here underneath onto our board, we already see signs that maybe somebody was already in, because all over the board we see solder joints which has already been soldered on. So you see the residue here on the board more or less everywhere. So it seems that somebody has already tried to look out for dry solder joints or so. Yeah, so you know, that makes it even more complicated because now we do not have a clear status. So let's see. Okay, so let's inspect the board here with the microscope, and well, if we go over it, we really see everywhere here residue from an earlier repair, I believe, because well, if you see the quality of this work, I really wonder. Have a look. So here we have nearly a bridge or whatever, but yeah, to be honest, I can't believe that this is a factory work. I mean, it is normal that sometimes a product which failed in final testing, that we really have to reflow it here and there, that a product will finally work. But honestly, I do not think that it really looks like factory work. So I believe that most likely somebody else has been in earlier, and so that means that the fault was known, and yeah, somebody already tried to fix it, and so really ugly solder joints, a lot of residue. So yeah, you see it. I do not really need to comment it, but yeah, that really does not make it easier, as now we know that somebody else already was in, and yeah, so what can we do? That is here really the question. I think it is a good idea first trying and cleaning it up, so that we have at least the residue away here from our board, and maybe then we see a bit more, but yeah, hopeless. Okay, so that is the cleaning process. So I really try to clean here the whole board, that we get off here the flux residue. So maybe that it is then easier to see if there is maybe an open solder joint or such. But anyways, this is always not easy, because it is not constant. So that is one point, and the other point is somebody else has already been in. So that all is funny, and additional to that, I do not have a schematic for this power supply. So yeah, you see a lot of points which are not really nice. Okay, so I have here now our power supply in test configuration on the bench, and yeah, it is connected, and it is switched on, so you can see that the control is glowing here. And I can tell you so far that it is again a similar situation. If I press here or there on the board, I have suddenly output voltage, and all looks like that we have a kind of loose connection, but so far we were not able to find where it is. So I try to move and wiggle here a little bit on the board, trying to find out where our problem is. But so far, I have no clue where our loose connection is. So maybe we need to flip it over, that we have direct access to our solder joints, and maybe that we can go then step by step to see where the problem might be. Okay, so I flipped it over, and the situation is now, when I push it here, you can hear a click, and then suddenly our output voltage is there. So that is really funny. Don't know if you hear the click, but it is really, when I touch it here, gone, and back there. So maybe, I mean, this both solder joints are really looking ugly, so maybe that that is already our problem. I don't know, but sure enough, if I press it here, I'm able to get output voltage, and my electronic load is switched on, so current can be drawn as well without collapsing voltage. And when I take it away, it is dropping. Okay, now you have the best look here onto our meters, and yeah, you have seen the point where I have pressed or touched at least a little bit the board, and now I'm doing exactly the same. I'm on the same location, so now I have released here my pointer, and now it is collapsing, and when I go back to that point on the board, you see the voltage is coming up. So what I'm going to do right now, I will reflow exactly that area, and maybe that is then already solving our issue. Yeah, so that is the situation here on the board. So that is a point where I was pushing just a little bit. So maybe that we really have here a problem with this joint. I don't know. It is not clearly obvious, but what I'm doing, I will suck off here the old solder, And yeah, then let's see when we reflow it if we are able to solve it. Well, our solder action doesn't finally solve the problem, but I was able to narrow down the issue a bit, and I know by now that when I just move this coil a little bit, I get my output voltage, so that is sure. And I do not really know if that is really an issue here with this little yeah, it is a kind of transformer or a choke. So I'm quite sure that something is wrong here with this component, because yeah, don't know if you can hear this little click which indicates that the voltage is back. And just when I move this component here a little bit, then I get this little click and the voltage is back. So not sure. So pity is that I do not really have the schematic for it, because then I would be able to know what this component is doing. But for now, I will see once again the other side. I flip it over and let's see if I can find something here. By the way, you see me working here on the open switching power supply. Remember, we really have high voltages here, over 400 volt or so. And so I have connected here this board or this circuit finally to a transformer, a security insulation transformer, so that I reduce here my risk of getting a shock. But that does not consequently mean that with an isolation transformer you can't get a shock. So if you don't know what you are doing, never touch, you know, the board here and go with your fingers here inside. So that is really dangerous. Remember, if you are following alone, you do it on your own risk, so take care. And here is our suspect component, and yeah, it is a little transformer or choke or whatever. And well, if we look here under it, you see that we have, of course, here the wiring going here into this housing, and the wires here are soldered here to these pins which go finally through the board and get soldered onto it. And well, do you see what I see here? This little guy here. So that is our problem. So normally this little wire, so everything is fine, no problem, but this wire here needs to be soldered here to the pin. Otherwise it is, I mean, this is a through-hole technique, no question, and you put it here onto your PCB and you do your soldering on the other side of the board, and everything is fancy-pancy, so no problem at all. But if you have here a wire which is not completely here soldered to the pin, right, then you have exactly the problem we have seen here. And this, for instance, is how it should look like. So here is our little wire, and it comes out of our plastic housing here, of course. Then it has to be turned around, and it has to solder it down to the pin. And you see it here everywhere. So it comes up, it is turned around, and then it is soldered, right? And when you now put it through the holes in the PCB, then it will work. But if you have a situation like this here, then you have exactly the problem we are facing. And I'm quite confident if we now will solder it here so that we have a fixed connection here to our pin, and then when we put it back here into our PCB, then I'm sure that it will work. So let me do that. I solder it down here to the pin so that we have a good connection, and then I put it back into the PCB, and let's see what the outcome is at the end of our story here. Alright, so our little component is back in our circuit, and yeah, you can see it down there. And yeah, meanwhile I have tested it here, so I was really bending here our board, and I have moved it around and hit it, and yeah, I can assure you that it is completely working. And I mean, it was obvious that we had an open contact there, or an open wire there, and that was our fault, so that is really for sure. And yeah, if I go down over here to our load, we can see that it is completely stable, even when I hit here the board everywhere. And of course I can switch the load on, and you see that our power supply is delivering power, so everything is fine. And yeah, our fault is gone. Everything is completely under control, and yeah, that is really nice. And yeah, so I didn't know what the problem was when we started with this repair. It really could have been nearly anything, because this power supply is already a couple of years old, so it could have been some capacitors or on the board. So what we assumed first, that there is a cold that there was a cold solder point, and well, you have seen that somebody was in already, and the person who did this first repair attempt wasn't able to fix it. And yeah, I have to admit, this repair was a little bit tricky, because you never expect that you have a problem here at this component. So that is very, very seldom that a supplier of components like this have problems like this. So yeah, it is very seldom that something like this happened, but you see, everything is possible. And well, but on the other hand, now we really had a very exciting repair, and exciting finding, and I do not put it back into the housing. So I mean not now, because I do not want to extend the video. So I do it off camera, so we are sure everything is fine and working. And I just want to stop the video here. I hope you enjoyed it a little bit, and if you like it, please give me a big thumb up for the video, and catch you next time. Bye!